So part 2 of chapter 28, which is about the reproductive system. And we talked already about Sertoli cells, and I told you guys you need to know which cells secrete what. Some cells, not just the part, the cells. Some cells secrete testosterone, which is androgen. It's one of the androgen, the most important androgen. And other cells are responsible for spermatogenesis. And we call these cells Sertoli cells or nurse cells. So these cells are responsible for spermatogenesis and other things. But spermatogenesis, what's the difference between spermatogenesis and spermiogenesis? Is it the same thing? It is not the same thing. What's spermiogenesis? The, yes, the last step only is called spermiogenesis. But before that, the whole process, spermatogenesis. So spermatogenesis and spermiogenesis, this is a function of the Sertoli cells. Plus, it maintains something called blood-testis barrier. There is a barrier between the blood and the testis, just like the blood-brain barrier. Not everything in the blood go to the brain. Here, not everything in the blood go to the testes. There is a barrier. Who is responsible? Nurse cells or Sertoli cells. It also, besides spermogenesis and spermatogenesis, including mitosis and meiosis, but it also secretes inhibin and ABB. Each one of those have a function, and I will talk about it. So it's responsible for blood-testis barrier. Nothing much to know about that, except it's a barrier between the blood and the testes. And who is responsible for it? It is a Sertoli or nurse cells. Okay? So not everything in the blood goes into the seminiferous tubules. Supporting mitosis and meiosis. Um, it mentioned it. Support mitosis and meiosis. These are parts of the process of spermatogenesis. Remember spermatogenesis, the steps starting from the spermatogonia. So you go through mitosis and meiosis. Who is responsible for that? Sertoli cells or nurse cells. And who is going to stimulate these nurse cells? It is testosterone and FSH. Okay, what's the other one that goes with the FSH? LH. So this is FSH, not LH. LH is something else. Okay, we will talk about it. But FSH and testosterone, this is what stimulates the nurse cells to do its job. What's its job? Meiosis and mitosis. So support spermatogenesis and support spermiogenesis, and you understand the difference. You should understand the difference. It also secretes inhibin. What's inhibin? Inhibin coming from inhibit. It inhibits FSH and gonadotropin releasing hormone. Do you remember the difference? Which one is above the other? FSH or gonadotropin releasing hormone? Which one is above the other? Gonadotropin is above the FSH. Where the gonadotropin come from? Hypothalamus. And where the FSH come from? From the pituitary. Which one have the upper hand? Which one is the boss? Hypothalamus. So it is drop FSH and maybe gonadotropin releasing hormone. Why? Because these cells stimulate spermatogenesis. You're already doing the spermatogenesis. Why should you stimulate me more to do spermatogenesis if I'm already doing it? Okay? So no, I'm going to stop you. Same cells. So these same cells that stimulate spermogenesis and spermatogenesis, it's secrete inhibin to inhibit further stimulation that's not needed. Why do I need to stimulate? ABP is something called androgen binding a protein. The name gave it away. It is a protein that binds androgen. What does that mean? To make it simple, androgen is one of the hormones. Most of the hormones, when they float in the blood, they can easily go to the kidney and you get rid of it, or it can be broken down. It goes fast in the blood and can be broken down. If you attach a protein to it, that will save it and it will make it stay for longer time. So those that are attached to carrier protein, it give you longer lifespan. It stay for long time. If it is free, you get rid of it. Okay? So this is to make it to extend the concentration of androgen and to make the androgen stay for longer time. Okay, if it's attached to the protein, it stay more. Bottom line. Okay, and this is stimulated by what? FSH also. So after all of that, the sperms are going to leave with the sequence that we talked about before and go to the epidermis. At the epidermis, as it is arising to the epidermis, it's not mature yet. Remember the functions of the epidermis? Maturation and controlling the fluid, right? Adjusting the fluid. So maturation, so it's going to maturate in the epidermis, but it's still not mobile yet. It's immobile. And then it will maturate more and become motile. Motile or mobile is the same thing. So it will be like mobile and stimulated to move. It will be like swimming. And then capacitation will happen. What's capacitation? Capacitation means to be capable of fertilizing the egg or the oocyte when it finds it. This is capacitation. So it will become more motile and more capable of fertilizing the oocytes. This is capacitation. So motility, maturity, motility, capacitation, those three, they happen in epidermis, and all of them is maturating. When you maturate, you become mobile, you become motile, and you be capacitated. All of this means you're mature. Mature enough to penetrate and fertilize an egg. The different parts of the sperm, I talked about this, and I told you to know the function of each one of those, and you should remember. Head, including the acrosome. What do we have in the acrosome? Acrosomal enzymes to penetrate, right? You have to have it. And what do we have in the head? The nucleus containing chromosomes. And how about the middle piece? Mitochondria for energy. I'm just telling you one word to remember. I'm not overwhelming you. Just one word. Middle piece, mitochondria for energy. That's what I want you to know. Tail is for motility. That's it. When it is fully mature, the sperm, if it's fully mature, it will not have endoplasmic reticulum, Golgi apparatus, lysosomes, peroxisomes. It loses a lot of its parts that's not needed. I need the nucleus and the mitochondria. This is what you need. So you lose everything else because you don't need it. And it's going to absorb some nutrients, which is fructose, in order to keep maturating and moving. Which gland secretes fructose? And prostaglandin. Fructose, let's say fructose. Which gland? Seminal vesicle, yes. And which one contribute the major part of the seminal fluid? Seminal vesicle too, right? What's number two? Prostate. And what's minimal? Right, bulbourethral gland. So hormones that control the male reproductive function, and also it regulate the female as well. You will see the same too, FSH and LH, but they just do different function. And those two are in response to gonadotropin releasing hormone. Hypothalamus secrete gonadotropin releasing hormone. Go to the pituitary, in turn stimulate FSH and LH. Males and females, yes, but it does a different function. What's the function that you need to know? Read it. Follicle stimulating hormone. Stimulate the follicle that produce sperms in male. Stimulate the follicle that produce eggs or oocyte in females. So the name give it away if you understand it. Follicle stimulating hormone. So is that for the hormone? Does stimulate the hormones or the gametes? The gametes, whether it's males or female. Both of them? Yes, both of them. Follicle stimulating hormones stimulate the follicle, resulting in sperms in male, oocyte in female. Luteinizing hormone is the one that's responsible for producing hormones. Hormones. And luteinizing is coming more in females. And we will talk about that later. Because when you luteinize, this is when you secrete more hormones. I'm going to talk about it uh, later. So here is gonadotropin releasing hormone secreted from the hypothalamus, and it moved from the hypothalamus, go in a hypophyseal portal system to go to the pituitary gland, and in the pituitary gland, it's going to stimulate FSH and LH. Which one of those two stimulate testosterone? FSH or LH? LH. Yes. FSH, follicle, gamete. LH, hormone. Simple. That's it. You need to know that it secretes gonadotropin releasing hormone naturally is secreted in pulse. It doesn't continuously secrete it. Okay? This is important. Why? Because you give like a pulse every hour or an hour and a half, gush, and then you stop. Hour and a half, and then you give gush, pulse, like this. This is how to stimulate FSH and LH. Guess what? If this one is released continuously, it will do the opposite. Clear? It has to be secreted in pulse. Every hour, an hour and a half, gonadotropin releasing hormone, and then you stop. And then gonadotropin releasing hormone, and then you stop. If you do it in that sequence, you stimulate FSH and LH. If you do it continuously, you inhibit those. And what's the importance of that? This is one of the contraceptives. Okay? If I give you contraceptives that continuously secrete gonadotropin releasing hormone, it's going to do the opposite. It's going to suppress FSH and LH. In females, that will result in contraception because the eggs are not coming, the hormones are not coming. So whatever the function of FSH and LH, it's going to be inhibited. So FSH and testosterone, those two, they target the nerve cells in the seminiferous tubules to do the spermatogenesis. And then we talked about the nursing cell. What does it secrete? So, and we talked about inhibin that inhibit FSH and gonadotropin releasing hormone, so that what stimulate inhibin? The nurse, or the other name, Sertoli cells. So since nurse cells or Sertoli cells is the one that's responsible for spermatogenesis, it also secretes inhibin. So I am already in a process. Don't push me more. This is how it goes. So here is LH responsible for what? Testosterone. What's the difference between testosterone and androgen? Is it the same? No, it is not the same. Yes. Yes, exactly. Androgen is all of them. Every male hormone is called androgen. Testosterone is one of them, but it's the most common. And I always say it's like saying fruits versus apple. It's not the same. Fruits is all fruits. Apple is the most common type of fruits. Okay, fruits is androgen. Apple is testosterone. This is exactly how it works. Testosterone is going to stimulate spermatogenesis. These functions are important to know. Males have testosterone. So what does it do in males? Think about it. What the males do. Sperms. So the spermatogenesis. This is one. Sexual drive. It's a sexual stimulant, right? So those having low testosterone, they don't have enough sexual drive. They will be weak. So it stimulates libido. Do we know what's libido? The sexual drive. The sexual drive. So it stimulates sexual activities. So this is called libido. It's responsible for it. And also behavior. We know that males and females have a little bit different behavior, right? It comes from testosterone. It also stimulates muscle and bone. We know that muscles and bones are different from males to females, right? Secondary sexual characteristics, because at puberty, all of a sudden, there is a sudden gush or sudden increase of testosterone amount, and this will really result in secondary sexual characteristics. What are the secondary sexual characteristics? Everything that you notice when you see a boy turning into a young man, right? Whatever you think about it, right? Voice, muscles, hair, under the armpit, hair around the genitalia is growing more. Whatever you know already, what's the difference? You see a child and you notice that he's becoming a teenager, right? Or at puberty. All these changes are called secondary sexual characteristics. What are the primary? Is what you're born with. You're born with the genitalia, with the testes, right? So testes, this is the primary. And also responsible for the growth of the rest of the tissues, the secondary tissues. Sometimes it converts into dihydrotestosterone. You just add dihydro. And it's not much difference. It's just another version of it, but not the major part. Dihydrotestosterone. Estradiol. What's the estradiol? Estradiol is one form of estrogen. Remember androgen? Estrogen. There are different types of androgen. There are different types of estrogen. Clear? There is testosterone, dihydrotestosterone. What are these? Androgens. And there is estrogen. Estrogen can be different things. We always call it estrogen. But estradiol is estrogen. Estrone is estrogen. There are different types. Estradiol is one of them. But we are talking about males. Yes. Males produce estrogen. Yes. They produce estrogen in small amounts. Okay. So part of the testosterone is will change into estradiol, especially it happens from the fatty tissues. And males do have small amount of estrogen. That does not affect them. If it goes more than that, it can affect. It can have some feminine or feminine effects. So as long as it's within the normal range, it's okay. Now the females. Female reproductive, we have primary and we have secondary, just like males. So we will do it one by one from the ovaries to the uterine tubes, uterus, vagina, and external genitalia. And we saw that already in the lab and you did the lab exam. So I'm assuming that you guys should remember this. So I always start from the ovaries, right here, the white, from which, and we have this big model of the ovaries. Do you remember this? Primordial follicles, primary, secondary, tertiary, and so on. So we will see it later, but here is the ovaries. And the ovaries are attached to the uterus itself by the ovarian ligaments. And ovaries, during ovulation, and ovulation is the release of the secondary oocyte from mature Graafian follicle. Do you still remember that? Do you remember that model when there's a big one that's opened and something coming out of it? What's that something coming out of it? This is a secondary oocyte. Surrounded by what? Does anybody remember? Does the secondary oocyte just come out of the follicle alone? Or there is a little bit of tissues around it? There are some cells, tissues around it. What is it? Start with C. C-O-R, corona, corona radiata. Corona radiata. These are, it's just take part of the follicle with it. Just, it doesn't like exit as it is, just like that. Like if you take the yellow out of the egg, don't you get some white? Right? This is exactly the same. It takes some of the cells around it. So when it leaves, this is called ovulation. It go through fimbriae, and the fimbriae are finger-like projections to suck it in. Any function that I'm saying is important that you need to know. So it will suck it in. And then it goes to this part, which is the ampulla, moving into the fallopian tubes or uterine tubes, same thing. Or the oviduct, same thing. On its way toward the uterus, if there is sexual intercourse happening, the semen is going to deposit it in the vagina. It will enter from this. What do you call this? Exactly this. Os, cervical os. So it moves from the cervical os, go through the cervical cavity to the uterine cavity, exit. Not all of them. Like it's going to drop as you go. A lot of these sperms are going to die. But the strongest of all are going to bypass all of this and go exit out to the uterine tube. The secondary oocyte will be coming from the other side, and this is where fertilization occur. It occur in the fallopian tubes. Okay. Otherwise, uterus and hopefully you still remember there is endometrium, myometrium, right? You still remember that? Perimetrium, the surrounding, the muscle is myometrium, right? And here is vagina right here. And at the entrance here, this is called labia majora. This is labia minora. You guys did the lab, so I'm assuming that you guys should remember. Labia majora, labia minora. And what is this? Clitoris. This is the most sensitive part of the female external genitalia. All of these, the external together, there is a name for it. Labia majora, labia minora, and clitoris together. Vulva. All three are called vulva. Okay? Whatever you can see from outside is called vulva. Inside, it's the vagina. And there is a gland at this here, at this part right here, that's called greater vestibular gland. This is kind of equivalent to what? Bulbourethral gland. Okay, so you will see some similarities in males and female organ that you need to know. What is equivalent to what? It's not, remember, males and females, they start as same origin and then they differentiate into two different cells. So it's not like 100% different. Okay, there are a lot of similarities that you're going to see. Here are the different parts that I talked about: endometrium, myometrium, and perimetrium. And the zygote attached to which one of those three? When the zygote form in the fallopian tube, it goes into the uterus to attach to which one? Endometrium. It attached to the endometrium. Endometrium itself is two layers. It's two parts. It attached to the functional layer. You will see it. So here it is. And the rest, I talked about it. There are some ligaments that you guys need to know. The biggest one, the major one, is called broad ligament. Why did you call it broad ligament? It's broad. It's wide. It's this big one, broad, going to the side like this, including the uterus, including the cervix, including the ovaries. It goes like this, like a sheet, like that, to get every or most of these on its way. Uterus, the uterine tube, and ovaries. It include those. So if you look at this picture right here, here it is. Can we see it? Here is the uterus. Here is the cervix. Here is the fallopian tube. Here are the ovaries. It's covering all of those. It extends. It's broad. It extends out until it gets all these, and this is called the broad ligament. There are certain pouches because of the presence of, like if you look here, not this, look at this here. You see this bladder in the front, right? And this is the uterus, and the rectum is at the end. You see three behind each other. So in between each two, there is a pouch, okay, like a space. And the space is very easy. It's a space between two things. So the name comes from the two things, as simple as that. So here it is, recto-uterine pouch. What do you think? Between what? The rectum and the uterus. The name gave it away. That's it. This is a pouch in between those two. Vesico-uterine pouch between. Vesico is the other name, or vesicle is the other name. Vesico is the other name for the bladder, for the urinary bladder. So it's between bladder and the uterus. Okay. Ovaries. There are always two ovaries, and the ovaries produce oocyte, just like the testis producing sperms. It also secrete estrogen plus progesterone, right? This is the additional one. And it also secrete inhibin, just like the testis. Testis do the same thing. There is something called mesovarium, and this is kind of mesentery that's stabilizing the ovaries in place. There are also the ovarian ligament, and from the name, it's a ligament that hold the ovaries in place. There is also suspensory ligament. And this suspensory ligament, from the name, suspend the ovaries. So there are two ligaments. Yes, ovarian ligament is one, just attaching the ovaries to the uterus. Okay, this is the one that's in a side. So the ovaries have two ligaments, not just one. One of them is the ovarian ligament from ovaries to the uterus. And there is one above suspending it in place. And this is where the name suspensory ligament came from. Is it only suspending the ligament and the ovaries and that's it? No. Remember, always, 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 when you see something that's keeping an organ in place, it also provides a route for different things to come in and out. Do you remember that in the digestive system? You don't have a fold that's doing just one function. It keep it in place. No. Besides keeping it in place, it provides a pathway, a route or a route to the arteries and veins and nerves, right? And this is always, always the case. So if you look at this picture, this is a good picture showing you. Here is the broad ligament right here. These are the ovaries. Look at these two. Here is one, the ovarian ligament. And look at this one up here. You see how this is above? So it is suspending the ovaries. And you see what's inside of it? Arteries and veins and nerves and so on. Mesovarium is this part. Varium, mesovarium is, you see it, it sounds like ovarium or ovaries, right? So it is this part of the broad ligament. You see the broad ligament is two parts. Here is the main part, this part. This part up here is called mesovarium. So this is the third one. How many ligaments related to the ovaries? Three. Ovarian ligament, suspensory ligament, and mesovarium. And so if you look inside the ovaries, and this is something that we noticed and we went through it in the lab, you always start from the sequence of primordial follicles, and primordial follicles become primary, secondary, tertiary, or mature, which is this. And these tertiaries or the mature, what's going to happen to it? Release oocyte with some cells around it, right? So it's going to release. When it releases it, the fimbriae are going to pick it up. Is that right? Released. And what do you call it? The process of releasing it? Ovulation. So ovulation, how about the remaining parts? Do we throw it away? Of course not. It's going to change into this yellow body that you see here. Corpus is body, luteum is yellow, the yellow body. Why do you keep it? Why it change like yellow like this and you keep it? It stay. Why? Because it secrete estrogen and most importantly, progesterone. This is where the progesterone come from. Okay, and why is it linked for this? Simply, it's common sense. Everything is common sense. Why is it linked to the corpus luteum? Because you will not have a corpus luteum unless you have an ovulation, right? So if you have an ovulation, it means you have a secondary oocyte. And there is a possibility that it get fertilized. Common sense? Make sense? So because there is a possibility to be fertilized, when it's fertilized, it will move and insert itself into the endometrium. The endometrium need to be ready, right? The endometrium normally is not ready. It should be ready. I have an oocyte, so there is a chance. As long as you have oocytes, there is a chance for fertilization, right? So as it is moving, you need to prepare. It's moving toward what? It's moving toward the uterine cavity, isn't it? It's moving toward the endometrium to be attached. You have to prepare the endometrium to prepare it with what? Estrogen and progesterone. But ovaries secrete estrogen. Yes, corpus luteum secrete both. But the additional here is progesterone. Progesterone is progestation. So it's going to prepare the endometrium in order to be ready to receive the zygote that's going to attach. It has to be ready. And I will tell you what I mean by ready. So here is inside of the ovaries. There is a cover that's called tunica albuginea, and there is a stroma inside. It's the important part is just to know that cortex is the outside and the medulla is inside, which is always the case for any structure, glands, or anything similar. Everything. You have a cortex outside and a medulla inside. Uterine tubes, fallopian tubes, oviduct, same thing. Transport oocyte. Remember, it doesn't transport the ova. Ova is wrong. We agreed on that, right? We don't say ova. It's called the secondary oocyte specifically. So it transported from the fimbri that pick it up to the ampulla, moving within the uterine tube, moving toward the uterus, right? How does it move? How does it move? There is peristalsis, right? Do you remember the peristalsis? Like the ova is here. What will make it push through? What will make it move? Peristalsis. Smooth muscles contract, pushing, 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 pushing. Okay, so these peristalsis, so the oviduct or the fallopian tube or uterine tube is to transport the secondary oocyte toward the uterus, and and to move it, you have to have peristalsis, plus you need to feed the secondary oocyte as it is moving. So it also supply nutrients for the oocyte. So the oocyte takes time actually in order to move this journey. So as it is moving, you give them nutrients and you do peristalsis to move. So here is infundibulum with the fimbri. So the first thing that pick it up is the fimbri, go to the infundibulum, followed by the ampulla, which is the middle segment, and the last part is the isthmus, which is the final part. Okay, so look at this. Fimbri, infundibulum, infundibulum, ampulla, and then isthmus. And then it go to the uterus itself. What do we do? I already told you. It gave nutrients and peristalsis, and the third one is cilia to push it. So how does the oocyte move? Cilia, cilia is like this, like a brush. Okay, cilia to push it, and peristalsis also to push it. So it has two ways to move it: peristalsis and cilia, plus supply nutrients. So this is how it looks like. These are the cilia that push it, like brush it, like a brush to push it, and the peristalsis. Both of those are going to help moving it. So the secondary oocyte will be moving from the fimbri and moving toward the uterus. Okay, this journey will take about 12 to 24 hours. It is that slow? Of course, for a reason. If it goes like this in a minute or 5 minutes, there will never be fertilization. So this is happening in purpose. 12 to 24 hours, giving enough time for a sperm to come and fertilize. Okay, so this journey again take from half a day to 1 full day to move that journey. If a sperm come during this long period of time, and females should know when is that going to happen. So once the ovulation occur, you know that after that you have like 12 to 24 hours in order to fertilize the egg. Otherwise, this secondary oocyte, if it reach the isthmus and go to the uterus, it's over. There is no way for fertilization. And fertilization occurs specifically between the ampulla and isthmus. Specifically, it is the fallopian tube. Yes, which part of the fallopian tube? Most likely between the ampulla and isthmus. At that time, capacitation of the sperm happen, and it can penetrate and produce the zygote, which is the pre-embryo. Uterus, it's the organ, of course, that's going to house the zygote or the embryo. And we always hear embryo and fetus, and there is a difference between those two. Okay, embryo is not the same as fetus. Embryo is only the first 2 months. After 2 months, you don't call it embryo anymore. So isn't it different? It's different. Okay, so it's between week 1 and week 8. This is what we call it embryo. How about before that? Week one, it's a zygote. Okay, zygote. Zygote is the first week. From week one to eight, which is the first 2 months, you call it embryo. After that, until delivery, you call it fetus. Okay? And of course, the uterus is going to provide protection, mechanical protection, nutrients that I'm going to talk about, and waste removal. Whatever the waste that's there in the uterus will get rid of it, including the period, right? The menstruation. The uterus will get rid of it. Normally, the uterus is anti-flexed. Anti means front. Look at this. The uterus is not like this. It's not uterus vagina like this. No, it's bending. And normally it's bending forward. In some people, it's bending backward. Okay, it's not something bad or a disease or something. It's just minority of cases. The more common is that bending forward. We call it anti-flexion. Anti is forward. Retro is backward. Anti-retro. Front, back. Uh, the ligaments of the uterus, we talked about the broad ligament. Here is another ligament, uterosacral ligament. Of course, it's between the uterus and the sacrum. The name gave it away. Round ligament, and this extends toward the inguinal canal. And cardinal ligament is at the bottom. Okay, and the different parts, besides the layers, you have the fundus on top. I think you guys know that already, right? Fundus, body, cervix, right? And this is the blood supply. It's called uterine artery to the uterus, ovarian artery to the ovaries, and uh, uterine artery and ovarian artery. I'm sorry, or uterine artery and ovarian artery. Uterine artery goes to the uterus. Ovarian artery go to the ovaries. Here is the uterine artery and uterine vein going toward the uterus. This is vaginal artery going to the name gave it away. Ovarian artery to the ovaries. Uterine artery to the uterus. Vaginal artery to the vagina. Everyone has its own name. Nerve supply, there is sympathetic and parasympathetic. Okay. The sympathetic come from the hypogastric plexus, and the parasympathetic come from the sacral plexus, from 3 to 4. Do we have sympathetic and parasympathetic supply to the uterus? Yes. And we do have sympathetic and parasympathetic in males as well. Okay. Which one do you think is responsible for the first part, which is the sexual excitation, the sexual excitation and arousal? It's not the sympathetic. It's the parasympathetic. This is the relaxing one. Sympathetic is the final part, which is during orgasm and all these contractions. This happened because of the sympathetic. So it starts with parasympathetic for sexual excitation and stimulation, and orgasm during which there are contractions and secretions. So these are active things that are happening because of sympathetic. So both of them work together during the sexual intercourse. Endometrium, myometrium, perimetrium, I talked about that already. And the myometrium is what have the muscles, which is the thickest part. For the endometrium, it's important to know that there are two layers. There is a functional zone or layer, and there is basal layer. Clear? Endometrium is not one layer, it's two. Is that clear? Functional layer or zone, this is the innermost. Basal layer is around it, surrounding it. Are we clear? The functional zone is the zone in which the zygote will attach. At the same time, it's the zone that will be sloughed off during menstruation. Okay? So during menstruation, is the endometrium, the whole endometrium sloughed off? No, it's just functional zone. Basal, no way. Estrogen is the one that stimulates the endometrium, the functional zone specifically, to become thicker and larger. So here it is, become thicker, like what you see here. The arteries extend. And if you look at this purple here, this is the endometrium. And the endometrium itself is two layers, it's two parts. The one that's toward the cavity inside is functional. And the one inside, more toward the muscle, is basal. And you cannot lose the basal. So here is functional zone and basal zone. Functional zone, two things. This is the one that becomes thicker and later will have secretions for the attachment of the zygote and later producing placenta. And this is the one that be sloughed off during menstruation. Basal layer is just the base, support. It's only support. So what happened to the endometrium? There are, oops, there are two different steps that will happen, and I will talk about it. The first part is the functional zone of the endometrium become thicker. This is the first part. Next, it will continue to become thicker, but secretions and nutrients will be added. Okay, it's like this. This is the endometrium. The first part is, let's say, this is right after the menstruation. Okay, menstruation ended, so this is sloughed off. You don't have functional zone. Clear? So what's going to happen? Estrogen will make it thicker, rebuilding. Okay, thicker, 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 thicker. All of this is estrogen. This is the first half. Okay, progesterone will come. Not only that would continue to be thicker, but secretion. So we call that the secretory or the secretory phase. So it always go into those two phases. So there are different arteries that supply. Arcuate artery is the one that's arcuate means arc. So this is the one that's encircled the endometrium. And then the radial arteries, which is straight and spiral. Straight is the one for the basal. Spiral is the one in the functional zone. Why? Why is it spiral? Because if it is like this and it gets thicker, if it is straight, you're going to cut it. But if it is spiral, it's okay that you can expand it. Okay? Vagina is the next part. Nothing much to know, but the function is sexual intercourse and getting rid of the menstruation, right? I think we all know that. But before the first sexual intercourse, there is a thin layer that's closing the entrance of this vagina. What do we call it? The hymen, right? Is the hymen completely closing the entrance? Of course not. There should be an opening so that the menstruation can leave, even though the hymen is still there. But there is an opening there that allow uh, the the, um, the menstruation or that blood to leave. Uh, Sometimes, just for your information, sometimes some girls have it that's not opened. There is no opening. What do you call it? Imperforate hymen. Sometimes it happen and like the girls are really scared. Like I'm 15, I'm 16. What is this? I'm not having the period, but I have pain here. Yes, it's imperforate. So the blood is going, but it doesn't leave. Accumulate, accumulate, accumulate. They look by the endoscope, they find no opening, they make an opening there. Okay? They don't rupture it, just make a small opening to mimic the original opening. Okay, here it is, the hymen. Okay, so here is the vagina, including fornix, and the fornix is with the cervix push in, making that fornix part. And there are muscles in there that's called bulbous spongiosus muscles. And here is the hymen that I talked about. It's epithelial folds that's blocking, but there is an opening in there. Okay, it will get torn during either sexual intercourse, the first sexual intercourse, or tampon. Some ladies use the tampon, and if it push up too much, it can end up rupturing it. And there are other reasons, but it's not our issue now. Um, so the vagina itself, the wall, just like any wall, contain inner layer and muscles in between. There are secretions that goes into the vagina, especially during sexual excitation, in order to lubricate. Okay, and the vagina from inside there are rojays. Why do you have rojays? Anything that expands, it has to has rojays. Do you remember the rojays inside the stomach? To expand, right? It folds like this. So the vagina should expand during the sexual intercourse, and that and what enable it to do that is are these rojays, so it can expand and then it goes back. And the vagina mucosa that have different secretions. So here it is, the vaginal canal. Remember, the entrance here is called the vestibule. Okay, the entrance to the vagina is called the vestibule. It have nothing to do with the vulva. The vulva is labia majora, labia minora, and clitoris, right? The entrance, that space, is called the vestibule. There are certain bacteria that's normal to be in the vagina, and I talked about that if you guys still remember, which is the lactobacilli. Lactobacilli is not bad. It's bacteria, but it's not bad. It's there to make lactic acid. So creating acidity. What's good with the acidity in the vagina? Two things. Number one, acidity kills the pathogens, right? As long as you have acid, it will kill the pathogens. This is one. Number two is it's also will get rid of the weak sperms. Okay, so it does have a function. Is it bacteria? Yes, it's bacteria, but beneficial bacteria. Inflammation of the vagina is called vaginitis. Vaginal smear can be done for different things, including um, uh, estimating the ovarian cycle. Like if there is a couple who are trying to conceive, they can go and take a swab and they can tell by the types of secretions which part of the cycle is it. Clitoris is the most sensitive part, anterior to the vagina. And then you have glands, lesser and greater vestibular gland. And I talked about this greater vestibular gland that's similar to the bulbourethral gland, right? Mons pubis. Do you know what's a mons pubis? This fatty part in the front here above the vagina, above the vulva, I'm sorry, which is this part here. Okay, so here it is. This is the opening. This is the hymen right here. The urethra is in the front, labia minora, labia majora, and here is the bulb. This is the clitoris here. And this part here is called the mons pubis. But I want you to notice something here. You see this cover? Here is the clitoris. Okay, there is a cover above it. It's called the prepuce. Does that remind you of something? For the yes, remember that prepuce, which is the foreskin for the glans penis. So is that similar? Yes. Here are the similarities that I want you guys to know. So prepuce here is that hood or that cover above the clitoris. So remember, in males, there is that foreskin covering the penis, the glans penis, isn't it? Here, the clitoris mimics the penis. Okay, they come from the same origin. The clitoris just enlarged a little bit, but the penis enlarged more, and it's a different organ, but they come from the same origin. So if I ask you, or if you see a question like that, what is equivalent to the penis in females? It's the clitoris. What is equivalent to the prepuce or the foreskin? It is the prepuce as well. Okay, so there are different types of similarities. Next is the breast, and the breast contain the glands, the mammary glands, and of course the mammary glands are responsible for lactation. What else do we have inside the breast? So here are the glands that make milk and fat in between, especially in young age. The fat is there to make the contour of the breast. And of course, when ladies like become older, they start to lose that fat, and the ligaments that are suspending the breast in place start to become more relaxed. So that change how the breast looks like. Okay. Of course, some ladies like do cosmetic surgeries and they change, but I'm talking about the normal physiology, which is the presence of fat and the ligaments will keep the contour and the shape. And of course, we have the nipple in which uh, the nipple in which these ducts are going to open, and the areola. Remember that in the lab, this pigmented area surrounding the nipple. So mammary glands is where females make the milk, right? And the milk is formed in the lobules of the glands, and then it's going to leave through something called lactiferous ducts. Lactiferous ducts. So what take the milk out? Lactiferous duct. Okay? It will make a sinus first. Are we following? These are the lobules. The milk is made here in the lobules. Okay? And then it's going to leave lactiferous duct. Before the lactiferous duct open into the nipple, it make a dilation like this. Goes like this. And then dilates and then open to the nipple. This dilation is called lactiferous sinus. So lactiferous duct, lactiferous sinus, and then open to the nipple. Okay? Like 15 to 20 of those. So here are the suspensory ligaments I talked about. Breast contain mammary lobules, glands surrounded by fat, and there are the suspensory ligaments to suspend the breast in place. And these are the ones that become weak later on in life. When these glands are active, the tubuloalveolar glands specifically start to produce the milk, and it completely develop in pregnancy. We know that the breast of the pregnant lady is different than the breast of a girl, right? That's not pregnant yet. So here are all what I talked about. Look at the purple. These are the lobules, and look at this. Can we see this? Lactiferous duct, and look at the dilation before it open, right here. We call it sinus, and then it's open into the nipple. Okay, and look at the white suspensory ligament, and then there is fat in between. Okay, and this is the structure, and we talked about the nipple and the areola. Oogenesis, remember the spermatogenesis? Oogenesis is equivalent to the spermatogenesis, and it starts, what do you call it? The very first menstrual cycle. There's a name for that. What do you call the end? The last one, when it stops, the menstruation. Menopause. How about the first one? Men, menarche. Arche is the opposite of pause. Arche is beginning, pause is stop. Start, stop. Menarche, men pause. Arche, pause. Arche, start. Pause, stop. Okay? So we start with the oogonia. Remember the spermatogonia, the stem cells? Here it's oogonia, become primary spermatocyte, oocyte, I'm sorry. And oogonia, oogonium is right here, and going to give you primary oocyte, still diploid. So this is mitosis, and it will give you one oogonium and one primary, and it's going to develop into more and more. But this is the first step. Stem cells give you primary oocyte. And the primary oocyte is inside the primary follicle. You remember those primary follicles and secondary follicles? So at birth, there are 2 millions, about 2 millions of primary oocytes. Okay, at birth, it's only primary oocyte. It doesn't go more than that. This is different than males. It only go to the primary oocyte and stop. Only at puberty, these primary oocytes start to do the meiosis one to become secondary oocytes, and that's it. It's going to stop at this. Are we following? So at birth, it's just a primary oocyte, and that's it. It stopped at this, and it continue as this primary oocyte all the way until puberty come. Now only it will become the secondary oocyte within the secondary follicles. Okay, so here are the primary oocytes that will, at puberty, it will give you the secondary oocytes. And then there is something that form here that's called the first polar body. When we talked about males, I told you guys about this. Do you remember that you start with one spermatogonium and you end up having four sperms? Do you remember this? While here you start with one oogonium and you end up having how many mature secondary oocytes? One. You start with one, you end up having one. Why not similar to males? It is actually four, but three of them are called the polar bodies. And these polar bodies will never become mature, useless. We will get rid of it. And that's exactly is the explanation of what I just mentioned. One oogonium, one mature secondary oocyte. While in males, one spermatogonium, four mature sperms or four sperms. So you get the secondary oocyte, and then you form the polar bodies. Two more polar bodies occur. So now there was one, and here is the other two. You end up having three. And the secondary oocyte will be suspended in metaphase two. Okay? So you call it secondary oocyte? Yes. It doesn't continue? No. It stopped at the metaphase two. Do you remember what's after the metaphase? Anaphase and telophase, right? No, that doesn't happen. It will stay like this. Can it stay like this for life? Yes. Your oocyte will stay like that. It's suspended, it's stopped, and it will never change to anything else unless there is a sperm that fertilizes. This is the only time when it will change from secondary oocyte to ovum. Did we get this part? Remember in the beginning I told you you can't say ovum. You can't say eggs. You can't say ovum. You have to say secondary oocyte. So how about if this girl or lady never got sexual intercourse and there is no sperm? Can this lady stay as is for life? Yes. Yes, she can stay with the secondary oocyte stopped at or suspended at metaphase 2 and never continue after that. So it is only when there is a sperm that does the fertilization at this point, the rest will continue. Is that point clear enough? So here it is. If the sperm come and the sperm, this picture is not very accurate because it doesn't enter like this. It enter and just release the nucleus inside. Only the nucleus that enter, not the whole sperm enter. Okay. And if the this nucleus from the male, which means fertilization, now and only now, secondary oocytes become the ovum. Ovarian follicles, we talked about those. We start with primordial follicles, and these primordial follicles will become primary follicle, which contain the primary oocytes. Here are the primordial follicles. Do you remember that in the lab? Primordial follicles, and then it will give you primary ovarian follicles, then secondary ovarian follicle, then tertiary. So what's the sequence? Primordial, primary, secondary, tertiary. Which one is the mature? Tertiary. The tertiary will accumulate fluid and make a space so that the secondary oocyte is ready to leave. Look at this. This is the oocyte. Here is the nucleus, and surrounding it are these fluids. And there is zona pellucida. Okay, and these are the granulosa cells right here. What is this zona pellucida? Why are you talking about this? Because when the sperm come, it will go like this. It will go until this point, and the zona pellucida will stop it temporarily. In order to open it, you have to use the acrosomal enzymes. Do you remember that? Acrosomal enzyme is what's going to open this zona pellucida. And guess what? Something that's very interesting will happen once the sperm penetrate, the first one. Once it penetrates, release the nucleus, this zona pellucida will become tougher and stronger, preventing anything else from entering. Okay? So how can we get like twins? Sometimes, occasionally, two of them come exactly at the same time. So there is an opening and both of them come in and then it close after that, which is exception, which is the twins. One type of twins. There are different types. Which type of twins is this? What do you think? Like if two sperms penetrate at the same time, identical, because it's the same ova, right? The same secondary oocyte. How about the non-identical? Two, two oocyte. How? Isn't it supposed to be one? Yeah, sometimes it happened. Instead of one maturating, two maturate at the same time. Just happened. And you have millions of sperms. So if you have two, two are going to be fertilized. Okay? So ovulation is the release of the secondary oocyte. No, I skipped part. So here, secondary and then tertiary. Follicular phase, secondary and tertiary. Yes, here it is. So now the ovarian cycle. What I just explained, starting from primordial to primary follicle, inside which we have primary oocyte, secondary follicle, secondary oocyte, tertiary, until the secondary oocyte is released, this half, this is called the follicular phase. Why? Because this is the time when I still have a follicle. As soon as the secondary oocyte is released, the remaining is not a follicle anymore. What do we call it? When the secondary oocyte leave, what do you call the remaining of the follicle? No, Graafian follicle is the one that releases the secondary oocyte. The remaining part of the follicle, it's changed to become what? Corpus, corpus luteum, right? So what do you call the next phase? Luteal phase. So the first part, primordial follicle, primary follicle, secondary follicle, tertiary follicle, Graafian follicle. So it's follicle, it's called follicle, follicular phase. Once you release the secondary oocyte, the remaining part with remaining half, the second half, will be dominated by corpus luteum. So what should I call it? Luteal phase, referring to corpus luteum. So follicular phase is from primordial follicles all the way until the tertiary. And at the level of the tertiary, it will become mature Graafian follicle. And there are two types of cells here, granulosa cells and theca cells. You need to remember the theca cells. This is the one that secrete estrogen. Do you remember the cells that I told you in males? Here we should be specific. Theca cells. There are cells are called theca cells inside these follicles. This is the one that release estrogen. You go all the way until the secondary oocyte is kicked out, and you call that ovulation, right? Does the secondary oocyte is ejected alone all by itself? No, it's surrounded by corona radiata. Corona radiata. It's part of the follicles that comes out. So here is the ovulation. It's a release of the secondary oocyte surrounded by corona radiata. Here it is, all of them together, primordial follicle, primary, secondary, tertiary, mature Graafian follicle releasing. Can you see this? Do you see this is the secondary oocyte, right? Look at this, the purple or the violet. Do you see this surrounding it? It took part with it, corona radiata. Next is the luteal phase, and the luteal phase is coming from corpus luteum, and it is the remnants of the follicle, the granulosa cells that will remain there. And the most important thing about the corpus luteum is progesterone. Progesterone. This progesterone is the one that's going to travel into the endometrium to prepare it. Does it also secrete estrogen? Yes, but the primary source is from the ovaries. Here it is progesterone is the most important one. So now listen to this. Ovulation occur, so you have secondary oocyte available, right? Picked up, moving into the fallopian tube for a possible sperm coming for fertilization, right? At this point, you need to prepare the uterus, maybe, right? So the corpus luteum is going to secrete progesterone. And this is the one that will make, remember those two phases? After menstruation, it will become thicker, right? This is estrogen. And this is correspond to the follicular phase. And then it will become, second half, it become even more thicker and secrete. And this is the luteal phase. Okay, so if you're linking those two together, I'm linking the ovaries because it happened at the same time, right? Follicles are growing at the same time that the endometrium is becoming thicker. Okay, and then when the release of the secondary oocyte occur, now I have the progesterone. So what happened to the endometrium? Even more thicker and secretory. All of this to prepare for a possible uh, uh, fertilization. So, what will happen later to the corpus luteum? It depends. I keep on saying maybe, right? In case if fertilization occurs. So, what will happen if fertilization actually occurs? A sperm coming, the secondary oocyte is coming, they come together, fertilization. Okay? This zygote is going to secrete hormone to keep the corpus luteum because you do have it now. So you should continue to have this thick secretory endometrium. Does that make sense? How about if there is no fertilization, no zygote? Who is going to tell the corpus luteum to continue? Nothing, right? So what happened to the corpus luteum? Degenerate, shrink, get rid of it. But it will become white, and we call it the corpus albicans. So did you get the difference between corpus luteum and corpus albicans? Doesn't do anything. Okay, it's just remnants. So it looks like white like this, and that's why they call it corpus luteum. And here is a uterine cycle I was talking about. The very first menstruation is called menarche, and the last one is menopause, and you should remember that. Okay, and the uterine cycle, or also known as menstrual cycle, stays somewhere between 21 and 35, but the average is very important. It's 28 days. So what do you think ovulation occur if it is 28 days? It's a day 1, 2, 3, 4, 14, 15, 17, 14 in the middle, because you start with primordial follicle, and day one ovulation occur in the middle. At the same time, this menstrual cycle is happening. So we usually consider it 28. Is it really 28? Maybe not, right? Every lady is different. Every girl is different. Can be anywhere between 21 and 35. So we take 28 because it's in the middle. Okay, it's the average. And here is menarche. Normally, it's between the age of 11 and 12. Can it come like 10 or 9? Maybe. It can happen. Can it delay until 14, 15? Yes, it can. So when I say 11 to 12, this is typically, not necessarily. It can go earlier than that, as early as 9, and it can go up until like 15. It can happen. So, what are the phases in which the uterine cycle or the menstrual cycle, same thing. Uterine cycle, menstrual cycle is the same thing. Okay, what happened here? Here is what happened. We always start with menstruation, and menstruation is shedding and getting rid of which zone? Functional zone. Functional zone, of course, when it sloughs off, there will be some blood and secretion, and you call all of that together the menstrual blood, right? It's not blood. It's blood and the cells of the functional endometrium and some secretions, all of this mixed, it goes out, and we call that menstruation. So this is the menstrual cycle. Now, there is no functional zone, right? And you're going to rebuild it. You rebuild it in two phases. The first one is proliferative, and the name gave it away. What's proliferative? Proliferation, right? It's not there. So you rebuild it and getting thicker, thicker, thicker. Okay? Until the ovulation occur, progesterone will come and causing the next phase, which is the secretory phase. Okay? So menstrual and proliferative, the first half, this is 14. Okay? Look at this. from day one to day whatever, five maybe, let's say five on average. Okay, this is menstruation. For functional zone is sloughed off. From there until the middle, this is the proliferative phase. The second half is called the secretory phase. So the first half, which is two parts, correspond to the follicular phase in the follicle, and the secretory part or secretory half correspond to the luteal phase under the influence of progesterone. So here is the menstrual phase. Again, it's called menstruation or menses, and this is basically the functional zone degenerates and it's lost together with some blood and other things, and we call it menses. And it's usually the first. It's the average is like 3 to 5 days. Can it be more than that? Yes, it can be 7 days, can be 8 days, but we always refer to the average. Okay. Some ladies have, or some girls have dysmenorrhea. What's this? DYS. Does anybody know? It's a prefix. It means what? Not exactly. You're close, but this means pain. So what's dysmenorrhea? What do you think? Painful menstruation, right? Dysmenorrhea, painful menstruation. It can occur, and actually it happened in a lot of girls, specifically in the beginning. The first uh, few, like a year or two, most of the girls or a lot of girls will have this pain, and this is kind of considered normal. They can get like painkillers or something, but it happened to a lot. And then proliferative phase, and this is under the influence of which hormone? Proliferative. Estrogen. Proliferative is estrogen, in which the rebuilding of the functional zone of the endometrium occur, and it become more thicker and vascularized. That's it. Become thicker and contain more blood vessels. That's it for the proliferative phase. And it is under the influence of estrogen. The only thing that I want you to know about the proliferative phase is become thicker and vascular under influence of estrogen. That's it. So look at this. This is the functional zone, and this is the basilar zone, and then the muscles. Functional zone, this is the one that's going to show these changes that I talked about. So the menstruation plus proliferative phase, this is the first half. Are we following? The second half is the secretory phase, in which the name give it away. Is it only become thicker? No, it will show secretions. What secretions? Secretions containing nutrients. All of this, you're preparing for possible implantation. So secretory phase is totally ready for possible implantation. So here is the endometrium. If you look at it, functional zone, and it will change and become proliferative will become secretory, and the secretory is the one that's ready for possible implantation. And secretory phase is under the influence of progesterone. Okay, so this is the whole cycle together. You start from the hormones coming from the hypothalamus to the pituitary gland, and then it'll go to the gonads, growth gonadotropin releasing hormone. Does this come as continuous secretion or pulse? Pulse. It has to be pulse to stimulate the pituitary gland, and the pituitary gland give LH and FSH. To do that, it has to be in pulse. If it is continuous, contraception. That's going to stop the whole thing. Okay, so now FSH and LH are released, and I told you what is each one of those responsible for. Follicular phase is for follicles, for the growth of follicles until ovulation occur, right? And LH is hormones. But here is an important point. What happened at day 14? The second oocyte is kicked out with corona radiata, isn't it? Who caused these to be pushed out? sudden surge of LH. You need to remember this. It goes up all of a sudden like this. Specifically, it will not happen without that. If you want it, the mature follicle, to kick out the secondary oocyte, you have to have a sudden surge of LH. LH will go to this follicle and make the pressure on it to push and make the ovulation. And where does that happen? Mid-cycle, which is day 14. Um, okay, so you should remember that. Ovulation occur at day 14, which is mid-cycle. And what's responsible for it? Sudden surge of LH. You have to remember this. And here it is. Sudden surge of LH that will cause the ovulation by putting pressure, completing meiosis one, putting pressure on the follicle, so the follicle rupture and releasing the secondary oocyte. Okay, so you should remember that. So it is almost 7:20. So let's stop here.